welcome back to The Explainer. Okay, let's just dive straight into it. Today, we're unpacking a really fascinating technical walkthrough from MarkTech Post about building a production-grade AI agent. But not just any agent, we're talking about building one without the absolute chaos that usually comes with giving an AI way too much autonomy. If you've ever tried building an AI system and watched it just completely go off the rails, overthinking super simple tasks or worse, crashing your whole environment, well, this explainer is exactly what you need.
So, here's the million-dollar question we're tackling. How do you actually give an AI access to tools without causing total chaos? Because right now, the core problem we face in AI development is that giving an AI too many tools all at once is basically a recipe for disaster. It inevitably leads to wild model hallucinations, some pretty severe security risks, and incredibly slow processing times. The model just ends up paralyzed or totally distracted by the sheer volume of options sitting in front of it. To fix this, we've got to demystify two key concepts: dynamic tool exposure and MCP, which stands for Model Context Protocol. Think about it like this. Instead of throwing open the doors to a giant hardware store and telling your AI, hey, figure it out, this architecture gives it a highly specific surgical toolkit chosen for the exact procedure at hand. Dynamic capability exposure intelligently limits what the AI can see and actually do at any given moment, and it bases that strictly on the context of the user's prompt. Just contrast the two approaches. A standard AI agent has access to all its tools simultaneously. That bloats the context window and risks total confusion. But an MCP-routed agent, it only exposes the relevant tools. These clear architectural advantages of the MCP framework are what ensure both top-tier safety and blazing speed for real-world tasks. It's a total game changer. So here's our architectural blueprint for today. We're going to cover the AI tool overload, building the tool server, the hybrid router system, agent planning, and finally, real-world task execution. Let's get to it. Part 1, the AI tool overload. This is our core problem. Handing models every single tool at once completely bloats the context window, and that massively increases the risk of unpredictable behavior. Let's anchor this back to the real world for a second. When you send too much data, you break the AI's focus. Not to mention, you're literally spiking your compute costs for absolutely no reason. Why? Because you're feeding the model thousands of tokens of tool descriptions that it doesn't even need for that specific user query. Moving on to part 2, building the tool server. This is our modular foundation. You've really got to notice how disciplined the setup is in this tutorial. We start with step 1, defining structured pydantic models. This is absolutely critical to keep your inputs clean. Step 2 is building a local knowledge base, just so the AI actually has some context to work with. And step 3 is registering tools with very specific rigid schemas. We are enforcing strict boundaries from the literal first line of code here. So what's actually sitting in our server? Well, we're registering web search, local TF-IDF vector retrieval, dataset loading, and Python execution. Basically, we're giving our AI a really diverse and capable skill set. But as you'll see in just a second, the whole shebang is going to be kept under very, very tight control. Now, the absolutely crucial point here is how we handle that Python execution. Notice that it is completely sandboxed. We severely limit the built-in functions, we capture the printed output and local variables, and we completely isolate any errors. We have to sandbox this execution so our AI doesn't, accidentally wipe out a production server while trying to do some simple math. We're ensuring safety by design. All right, part 3. The hybrid router system. This is the intelligent brain of the whole operation. The system builds a genuinely brilliant dispatcher using a 2-step routing process. Phase 1 relies on heuristics, so keyword-based shortlisting. It is incredibly fast and trims the fat immediately. Then, Phase 2 brings in LLM reasoning to make the final routing decision. By combining the raw, cheap speed of heuristics with the deep reasoning of an LLM, we get an incredibly efficient dispatcher. And the result? The router guarantees minimal yet highly effective capability exposure. To reiterate why this matters so much, the router acts like a factory foreman. It evaluates the job that just came onto the floor, and instead of sending the entire factory workforce over to fix it, it sends only the exact specialized workers needed for that one specific task. Part 4, agent planning and execution. Let's look at the actual workflow. Here is the highly methodical workflow our downstream agent follows. Step 1. Discover exposed tools. Crucially, it only sees what the router actually lets it see. Step 2. Plan the tool usage. Step 3. Execute those tools safely. And Step 4. Inject context and synthesize the answer. Notice how strictly it follows the safe, structured plan dictated by the router. There is absolutely no rogue decision-making happening here. Actually, let's pause on that critical last step for a second. Context injection. This is the process of inserting specific, structured tool outputs directly into the LLM's prompt before it generates a final answer. This is vital. It guarantees the LLM has exactly the data it needs, no more, no less. Right at the very second it formulates its final response to the user, it completely eliminates all the background noise. Finally, part 5, real-world task execution. Let's see how it handles complex queries. The tutorial successfully put this system through the ringer across several demo scenarios: complex retrieval, computation via Python, real-time web search, and JSON RPC-style interactions. And honestly, this brilliantly illustrates the sheer flexibility of the system. It seamlessly adapts to completely different problem types using the exact same unified framework. It mirrors exactly how true MCP clients interact with a tool server. To summarize the real value of what we've just unpacked, the original author over at MarTech Post, Sana Hassan, puts it perfectly. She says, dynamic capability exposure improves both efficiency and safety, providing a strong foundation for building production-grade AI assistants. It's not just a neat little development trick, guys. It is the fundamental building block for scalable, enterprise-level AI. Which leads us to our final thought for today's explainer. How are you going to apply this routed, dynamically exposed framework to secure and scale your own AI projects? Are you still sending your models to the entire hardware store, or are you ready to build a surgical toolkit? Think about it. Challenge yourself to really rethink your current architectures. Thank you so much for tuning in, and I hope this empowers you to start building smarter, safer systems today. Catch you next time.